Hello, everyone. Good morning, dear authors and invited guests. Welcome to Technical Session 8A. Myself, Karthik Bharadwaj, and this session would be moderated by me. On behalf of Global Knowledge Search Foundation and JR Solistic LLP, it's my great pleasure to welcome you to the ninth International Conference on Smart Trends in Computing and Communication, SMARTCOM 2025, Pune, India. The ninth edition of the conference is being organized in a hybrid mode. The physical event was held yesterday in Pune, India, and the virtual event is being held through Zoom yesterday and today, that is 30th and 31st January 2025. I hope you will enjoy the knowledgeable interactive session throughout the day. In this session, we have 10 presentations. Each presenter will be given 8 minutes for presentation and 2 minutes for question answer. On 7 minutes, I will raise a gentle reminder. If you have any query or any update, then you can write it to me in the chat box. There is another request to all the participants to stay connected with us till the closing remark. Before getting further, I would like to introduce you with today's session chair, Dr. Kilol Vishnu Prasad Panda. Dr. Kilol Vishnu Prasad Panda is currently working as an associate professor at Electronics Communication Engineering Department, Charles University of Science Technology, Gujarat, India. His area of interest are MIMO antennas, DRA, active patch antennas, and based antennas for wireless communication. He has published 30 plus journal papers and 15 plus conference papers. I request sir to kindly address our participants.
Hello.
Yes, sir, you are audible.
Okay, so a very good morning to all the participants, presenters, and Karthik. It is my privilege to serve this conference as a technical session chair. And seems all these particular areas were very, they are very interesting. Some of are based on the AI, some are artificial intelligence, machine learning, then, the AI-based training kind of research work. So I wishing you all the very best to all participants and requesting all of you please stick to the rules and kindly conclude your presentation within 8 minutes so that we can have the question and answers appropriately. So my best wishes to all of you, and I hope you will be stay join here till the session ends so that you can have certain ideas from the other papers as well. So my best wishes to all of you, and you may start. Karthik, over to you.
Thank you, sir. Thank you for motivating our participants. Now moving towards the first presentation of the day. For the first presentation, I would like to call Sheila for the paper title AI-powered digital stethoscope for telemedicine applications. I request presenter to kindly proceed with their presentation.
Good morning, sir.
Yes, ma'am. Good morning. You can proceed with your presentation.
Yeah. One of the authors will be presenting. Is that okay, sir? Or do I need to present?
Ma'am, that will be okay.
Yeah. I will be sharing the screen.
Please, ma'am, tell the name of the author who is presenting.
Subhash.
Okay, ma'am. Thank you.
Subhash,
I'm
over to you.
okay. Good morning, sir. Good morning, everyone. Today we are presenting our paper AI-powered digital stethoscope for telemedicine, and uh, ma'am, next slide. And these are all the contents of the presentation. That is motivation, objective, introduction, methodology, uh, a flow chart, conclusion, future scope, and also the references. Coming to the motivation, main motivation for developing this stethoscope is the discomfort that doctors are facing, and uh, enhancement in diagnostics and data storage, because there are many disadvantages in the conventional stethoscope, and we tried a lot to overcome all those things, like enhancing the diagnostic, storing data, and to support the healthcare professionals, which helps a lot for their profession. we have three main objectives for this uh, project, and they are all the first one is designing a digital stethoscope that captures a real-time heart and lung sound. We designed to capture the heart and lung sound in real time, and we are using machine learning algorithms to classify the heart sound as normal or abnormal, and we are making this device IoT enabled by employing cloud and also the databases. And here is the flow chart of the project. And first we will capture the heart and lung sounds from the patient. So we are using a stethoscope into which we have inserted a condenser microphone, which converts the heart sound into electrical signals. It is stored in the form of dot wave file, and it is amplified using amplifier. And to remove the noise, it is filtered by using a low pass filter. Then we are applying NMF algorithm to separate heart and lung sound. After separating using lung sound, the intensity and frequency of the lung sound is calculated, estimated, to find whether the person is having wheezing or not. And using the heart sound, the heart rate of the person is calculated. And also, and further, the heart sound is gone into the machine learning algorithm, that is CNN, where we classify the heart sound as normal or abnormal. And after that, all these outputs are displayed on a display to make sure a doctor can view all this data. Meanwhile, it is uploaded to the cloud, where one can access, a patient or a doctor can access those data which are recorded earlier. And this is the output of NMF algorithm. After applying the NMF algorithm, the original heart and lung sound, that is combined heart and lung sound, is separated into the cardiac sounds and the respiratory sounds. And this makes an opportunity to get the clear sound of heart and lung sound. And this is the data set description for which we use this to train our model. Here we have taken about 350 abnormal sounds, and about 85 normal sounds to train the model. And we are more concentrating on abnormal sound, because it is very important to classify one's abnormality of the heart. As this is a early stage diagnosis, it is very important to concentrate more on abnormality. So we are using more abnormal sounds to train the model. And this is the pre-processing of the for giving input to the model. And the we will record heart and lung sound, which is in the waveform. And we will convert it to the MEL spectrograms by following certain techniques like STFE, logarithmic operations, and all. After converting it into the spectrograms, again it is converted into MFCCs, so that and again it is reshaped to 4 dimensional input for to make sure that model works properly. And this is the plot of model training where it is telling the wave plot, smell spectrograms, and also the MFCCs. And this is the confusion matrix for which is used to calculate the precision, accuracy, and recall and F1 score of the model, which gives this is the which gives information about how the precision, recall, and accuracy is calculated. And in the next slide we will see the our model performance. is for classifying the heart sound as normal or abnormal. We have used CNN, that is convolutional neural networks, where this confusion matrix shows the true positive as 56 and true negative as 18, and only false positive or only 4. So from this we have calculated the accuracy of the model, which is 92.85, approximately 93% accurate, which is really great. And the model we have tested again is the people who are having abnormal sound. It is almost accurate, as it is showing 93%. And this is the classification report, which is showing the F1 scores and F1 scores of normal, abnormal, accuracy, and macro averages and weight averages. And in the next slide, next slide, please. And this is the AWS EC2 console, which we have designed to store our database,
Sorry to
that
interrupt,
is
sir, but you have
to
1
run
minute
our
to
database.
conclude.
Okay, okay. Okay. And these are all the results. That is heart rate estimation. Next. Classifying the heart sound as normal or abnormal, and we have tested a normal heart sound. And this is the website where we can access the patient data, and also we can download the data from download the heart sound from there. And coming to the conclusion, we have achieved the real-time recording, real-time estimation of the heart and lung sound, the heart and heart rate, frequency of the sound, and also the heart state, that is normal or abnormal. And also we have achieved 92% accurate model, that is CNN, for the classification. And we have also achieved data storage, that is which we can retrieve whenever we want, and irrespective of the place and irrespective of the device, whatever. And these are all the things we have achieved in this project. And these are all the references which we have gone through to get an idea of what we are doing, and why how we are doing. And we have mainly referred 4 papers. And I'd like to thank all the panel members who are present, and thank you.
Thank you, sir. I request our respected session chair, sir. Sir, do you have any questions?
No, sir, I don't have any questions.
Uh, Dr. Kilol Pandya, sir, do you have any questions?
Hello.
Yes, sir, you're audible.
Yes. Shubhas, I have one question.
Yes, sir.
First of all, you have stated in the slide that you have utilized the machine learning algorithm. Okay.
Yes.
So
Yes.
my questions related with that. that any other algorithm you have tried to do the same research? And second,
Yes,
if
sir.
you have, and the second question is, if you have tried the other algorithm, then can you tell us which are the advantages of using machine learning algorithm rather than the others?
Sir, I have tried with SVM LSTM, sir.
Okay,
SVM with SVM I got 62% accuracy, and with LSTM I got
correct.
58% accuracy. And the main
Okay,
reason that for choosing the CNN is feature extraction. So the CNN automatically extract the features. For SVM and LSTM,
okay,
we need to we need to extract the features manually, sir. So that I have by considering the accuracy and also the feature extraction process, I have gone with the CNN, sir.
okay. So my only one suggestion is whenever you are going to present this research further, or when you are going to suppose writing a paper, you need to mention all those things so that it would be even give you the better clarity that why you have utilized this ML algorithm. Okay, all the best. Best
Okay,
wishes.
okay, sir.
Thank you.
Thank you, sir.
Over to you, Karthik.
Thank you, sir. Now we are moving towards the next presentation. For the next presentation, I would like to call Mandar Kulkarni for the paper title Artificial Intelligence in Medical Imaging. I request the presenter to kindly proceed with their presentation. Request the presenter to kindly proceed with their presentation. Moving forward to the next presentation. For the next presentation, I would like to call Kamini for the paper title Automated Polycystic Ovary Disease Diagnosis from Ultrasound Using Deep Convolutional Neural Networks. I
Yes,
request
sir.
the presenters to kindly proceed with their presentation.
Sure, sir. Thank you, sir.
Ma'am, you can proceed.
Yes, sir. My screen is visible, sir?
Yes, ma'am, your screen is visible to us.
Okay, thank you, sir. Good morning, one and all. Myself, Kamini Solanki, and today I am representing my research paper, which have title Automated Polycystic Ovary, PCOD disease diagnosis using the deep learning convolutional neural network. So, PCOD is polycystic ovary disease, which is a condition in which ovaries of the women are in the egg in the ovaries of the women are not matured, or you can say partially matured. So, due to that reason, if the eggs are not enough matured or partially matured, your egg is converted into the cyst, or that cyst is in future the cyst may be converted into the cancer cyst. So in our research work we have early detection of a polycystic ovary. The reason why we are doing this PCOD prediction, because sometimes what happen, gynecologist applying different drugs on the ovary. If drugs are not suitable to the eggs, and eggs are not enough matured, at that time again and again they are trying different drugs on the ovary to improve the performance of the egg or improve the maturity of egg. So PCOD is a problem where eggs are not enough matured, so that fertility issues and weight gain, anxiety, mental and physical health issues, that type of problems are arises due to this PCOD. So main objective of our research is accurate the detection of PCOD using the deep learning on ultrasound images. So we are removing the traditional image, and in early prediction we are doing prediction of PCOD in early stage. So most of 34%, as per the research and review, 34% women are suffering from depression, and 45% women are suffering from the anxiety. So with the help of CNN for automated diagnosis, we are trying to solve that issues and prediction whether that woman is suffering from PCOD or not. It's a just first stage binary classification of whether that woman is suffering PCOD or not. So integrate into the clinical workflow and real-time sonography analysis. So this is our data set. We have taken this data set from the Kaggle. We have total 1,921 ultrasound images. From that, we have 80-20% ratio. 80% we are doing the training. 1,536 images for the training, and 385% images, 20% images for the testing. So here you can see this is the image of infected PCOD woman's ovary, and this is the normal non-infected image. So we are doing the binary classifications whether that woman is suffering from PCOD or not. Right, and later on, this is our first paper, and second, third is already published. In that paper, we have done the ages, find the ages of the egg, and then we checked that from the sonography of first day image, first day of the periods, first day, second day, third day, and 11th, 12th, 13th, 14th, and 15th. That day's images we have captured, and that we have compared that images with the previous images, whether our eggs are developed, matured or not. Right. So this is our first paper. For the pre-processing, we have used the normalization with the help of KRAS, and we have labeled each and image images, one for infected image and 0 for healthy image here. So figure 1, we have labeled figure 1 as an infected image, and 0 means non-infected image. So we have labeled them, and our training setup is we have done the 100 epoch. On 100 epoch, we divide that epoch 80% training and 20% for the testing. We split that train test validation. This is our proposed model. In proposed model, we have used the convolutional neural network, then activation function. We tried different activation function, but ReLU gives the good output. So we have taken the ReLU, then max pooling, then different types of flatten and density layers, then output layer. And our parameters, we have applied the parameters 21,95,553. This is the snapshot. We have made this. This is the image of our model. So graphical representation of the image of our model. So this is convolutional neural network. Then we have applied different activation. Then second layer of convolutional, max pooling, then flatten, density, and activation function, and density layer. And this is our parameters, total parameters, 21,95,553. So in the performance matrix, training 100% accuracy is, here you can see, this is the accuracy rate of testing. But before that, let us discuss this. In this, on the same data set, some of the authors have also tried. So logistic regression, there are different techniques. They have 92%. This author applied logistic regression on the same data set of the Kaggle. So 92%, random forest 96, then VGG 69, CNN 97.63, and this is our proposed model. CNN and deep learning that have 100% accuracy. And this is our training data set, testing data set. We have applied 385 testing image which is not trained, right? So it gives the confusion matrix positive means 232 images are positive, and our systems gives also 232 image positive. So it's accuracy 100%, and here also 153 are negative, labeled as 0. So our system also gives that all images as a 153, all images as a negative. So, this is the automation. Advantages are automation, then accuracy 100%, scalability is adaptable for the medical condition, and our future plan is to, after the completion of all stages, our second, third, we are currently in this third stage of this proposed model. So after completion of all research work, we are we are planning to integrate that algorithm on the sonography machine. So real time we can detect after the sonography, after taken the sonograph images of the sonography on first day, second day, third day, and 11th, 12th, 13th, and 14th of the periods date, whether the egg is matured or not. So our system will compare that images and suggest to the doctor whether that eggs are developed or not, matured or not. If not, then doctor can apply the different medicine, different drugs on the ovary for the fertilization in IVF. So this is the summary. Early prediction and better fertility management, and our future plan is to generate apply the same algorithm on the different diverse data set, which is real time data set, and extend our model to diagnosis other gynecological conditions. And this is the reference.
Thank you, ma'am. I request session chair, sir. Sir, do you have any questions?
Professor Kamini, very good morning.
Yes, sir.
First of all, very good literature survey you have presented. Also, you have compared your research with the other available research. So basically, you have tried to solve the PCOD problem with the help of CNN and deep learning. Okay.
Yes, sir. Yes,
so my question is there any ethical committee approval is required for your research?
Yes. Sir,
That is my
actually what
question, yes.
happened, we are not inject anything in the body. हम बॉडी में कुछ इंजेक्ट नहीं करने वाले, वी आर जस्ट इंटीग्रेट दिस algorithm with the sonography machine. So during the sonography, doctor can detect that this is the ovary. Our second is age detection of each and every egg. That paper is already published. So the doctor can predict that this type of eggs, suppose 150, around 150 or 200, it also count the eggs also. So out of 200, suppose 100 eggs are maybe matured in future. So the same that image is stored in the system. Then after woman comes at 11th day, 12th day, so our system automatically compare with the images of the previous images, current image with the previous images, and suggest to the doctors that eggs are developed or not. So doctor can take the decision based on that, whether we want to continue with these drugs or we want to change this drug. Sometimes what happens, doctors are trying on the ovaries for the IVF. And for that, if actually my real brother is a gynecologist and my bhabhi's sister-in-law is also gynecologist, so they suggest me, if system suggests us whether that drugs are suitable or not. with the help of algorithm.
Sure.
So we can so sometimes what happen कि वो हम try करते हैं ovaries पे, so we can predict that कि this drugs is not suitable for these women, so we can change that drugs in the early, so वो early पे
Okay.
ही predict
So
कर
your-
सकते हैं कि ये drugs suitable नहीं है इस
Yes.
woman के लिए.
So your research does not involve any kind of injection or something like
No,
that.
no,
Yeah,
no,
right?
no, 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 no.
Okay.
We are
Okay.
not
Okay.
inject anything in the body,
Okay.
inside
Fine.
the body.
Sure. So your topic is very interesting. I humbly request you to kindly go for the further research in this topic, and all the best
Yes.
for your future. Thank you.
Thank you so much, sir. Thank you. Thank you. We have also submitted a proposal to the CSI, sir. CSIR.
Okay, that's really
Okay,
nice.
thank you, sir.
Karthik, over to you.
Okay, thank you, sir.
Thank you, sir. Thank you, ma'am. Now we are moving towards the next presentation. For the next presentation, I would like to call Purnima for the paper title Design and Implementation of Latent Fingerprints Using Weighted Hybrid Optimization Techniques. I request the presenter to kindly proceed with their presentation.
Good morning to the organizer, panel of reactor, participating researcher. I am Purnima E. Gungurti, research scholar from SDM College of Engineering and Technology, Dharwad. And my research supervisor is Dr. S.B. Kulkarni, Associate Professor, Department of Computer Science and Engineering. So today I am presenting my presentation on design and implementation of latent fingerprint using weighted hybrid optimization techniques. So the index is introduction, motivation, objective, result and discussion, conclusion, reference, introduction. Let us know what do you mean by latent fingerprint. Latent fingerprints are the fingerprint which are accidental impression of fingerprint left on surface like wall, table, glass, utensils. So these latent fingerprints are invisible to the eyes. So latent fingerprints, so these are irregular fingerprints which does not enclose any clear rigid structures. So our fingerprint consists of the informations like ridges, values. Because of this, we are able to get the fingerprint information. Latent fingerprints are used in forensics for the proof for the crime scene analysis. This latent fingerprints remains to be complicated problem, generally of poor quality image when compared with the images acquired from the fingerprint sensor. So here, latent fingerprints act as an pivotal in forensic investigation due to their significance in law enforcement and biometric application. This study addresses the challenges in latent fingerprint matching by introducing a novel method, randomization gravity search forest algorithm designed to enhance performance and accuracy. The research focuses on pre-processing features, extraction, and fingerprint matching, utilizing FEC 2004 dataset for experimental validation. So base paper is, so I have used Kumar M and Kumar D 2023 and efficient gravitational search decision forest approach for fingerprint recognition with Journal of Science. So here we are using a fingerprint matching system often faces challenges like noise, poor image quality, and segmentation, which hinder the accuracy and reliability. So here we are using a bar filter technique as a pre-processing method for effectively removing the noise and enhancing the fingerprint image clarity. So here in fingerprint, so minutiae are the key points which are used here. So, minutiae features such as rigid bifurcation, rigid ending are precisely extracted to capture the unique fingerprint characters. So, we are using a novel method over here, that is randomization gravity search forest algorithm. So here, this framework achieves improved fingerprint matching accuracy and addresses the limitation of previous method, demonstrating previous performance on the FVC 2004 database. So, automatic latent fingerprint matching. So here we are using for the law and enforcement forensic investigations. So as an biometrics research, there are many advancements because of public desirable of their applications. There are still number of problems within the fingerprint matching system, despite numerous work and into creating the algorithm of the latent fingerprint matching system has been done. Among them is the biometric-based personal verification system. So where the criteria of identifying the recent sense has led the researchers to provide a latent fingerprint matching technique to matching fingerprint extraction, feature extractions. And then, so here we are, the motivation behind this is to implement an automated latent fingerprint recognition in an effective way to develop an automated fingerprint system in security and forensic applications. Latent fingerprints are frequent approaches that usually are in low quality, blur, incomplete, distorted. So manually, if you are lifting up this latent fingerprints, so we might lose the information. So whenever we are lifting manually the latent fingerprints, we are losing the information. It is not that well defined as comparatively when we are just going up with automated fingerprint recognition. The speed and accuracy of the traditional fingerprint identification technique are limited, but here when it comes with human interaction with feature extraction and image augmentation. The objective here is like key by employing a weighted method to balance enhancement, noise reduction, feature preservation. So this research attempts to create an optimum system that integrates several optimization strategy. The technology increases the accuracy and the speed of latent fingerprint identification by automating the enhancement process. So the workflow is here. The workflow is a pre-processing technique we are using segmentation, normalization, enhancement, binarization, and thinning process. Some models which are including pre-processing, feature extraction. So in feature extraction, we are taking the features of fingerprints such as rigid bifurcation, rigid split, rigid ending, rigid terminate. So which are acting to identify the minutiae feature crucial for latent fingerprint analysis. Feature matching. We are using randomization gravity search forest algorithm for feature matching, which will help us to enhance the dependability of fingerprint matching by identifying and removing inconsistent points. So here is the flow diagram. First, we give an input image that has to be normalized. After normalizing, the image enhancement has been done using Gabar filter. After the enhanced image has been passed into binarization, where it is converting the images into binary, that is gray, white and black. So then the binarized image, once again it is thin, where the richer size will be reduced by the pixel and it is thinned. And then the thin image is passed through feature extraction, where the ridges bifurcation and ridges endings are used as a feature extraction. Here, after feature extraction, we are applying an algorithm for matching fingerprint, that is randomization gravity search forest algorithm. So randomization gravity search forest algorithm, it's a combination of random forest algorithm as well as gravitational search for forest algorithm. So this algorithm combines Newton's law of motion as well as decision tree, where they are going to perform a really well improvement in the recognition of the minutiae features over here. So the algorithm implies here initially the parameters of the gravitational search and random forest algorithm, where it is at the initial it is set to null and the iteration begins with 1. Once the iteration starts, if the maximum it reaches, it goes with the fourth statement where j equal to 1 to the number of decision tree, where the best decision tree is equal to null. So it's just an approach where it uses the mass agent to construct the decision tree based on the random forest algorithm, producing an arbitrary
Sorry to interrupt,
response.
ma'am, but you have 1 minute to conclude.
Okay. So here the decisions are taken using mass agent, initial position, gravitational constant, and decision table will be decisions will be taken. The best decision will be considered as the new node, and it will be updated with the velocity and the weight mass of the agent, and the best node will be considered here. Result analysis. So we are taking the acceptational result with the precision 99.9, recall precision 99.9, F1 measures 91.9, as well as recognition rate, which is 99% all, which is outperforming for the state of arts when compared with the previous research which has done by the previous author, which is 93.9 precision, 96.25%, and recall is 95.06, F1 measures, and 96.25 recognition rate. So here it highlights the method superior reliability and robustness in fingerprint recognition to the existing approaches. So here it has been compared with random forest decision tree backpropagation neural network KNN gravitational search decision forest. So here the recognition rate is high compared with the previous research. And the table here gives the performance evaluations where compared with the previous researchers like random forest decision tree, backpropagation neural network KNN, gravitational search random forest. So here the proposed method has high precision, that is the positive rates compared with the previous, the recalls, the identification of the accuracy, the measures, and the recognition rates. So these are the generation of the key points where the input image from the database has been matched with the given images. So this is the output of the fingerprint matching, and here these are the colorful points are the key points. These are the minutia points where it has been used for the recognition of the which has been used as a feature recognition. Conclusion: randomization gravity search algorithm has been used for enhancing matching accuracy, suppressing the various techniques. So it addresses the challenge such as noise, poor quality image, ensuring high accuracy and reliability. The proposed fingerprint matching achieved 99.9 precision, recall, F1 measure, and recognition rate, outperforming gravitational search, decision forest, and random forest. So here we have used FPC 2004 dataset, which has been demonstrated here, robustness, making it as an ideal. The results significantly outperform the existing methods. So the future work is nothing but, so we want to build an automated latent fingerprint recognition. So comparatively traditional method where they are less reliable compare. So here automated latent fingerprints are more reliable and efficient in identification solutions. So these are the references which we have gone through. Thank you, sir.
Thank you, ma'am. I request session chair, sir. Sir, do you have any questions?
Yes, Purnima, basically you have chosen a very nice topic.
Thank you, sir.
So my question is, you have, utilized the randomization gravity search forest algorithm,
Yes,
and that is based on the fingerprint recognition. Okay.
yes, sir.
So my first question is, because your research is more related with the the investigation.
Yes, sir.
Uh,
Forensic.
so yes, so many forensic agencies would be involved in future. Suppose your research will get this success.
Yes,
So
sir.
is there any particular procedure you need to follow? Because see, certain things for your end it is fine. You have verified the result. But
Yes,
to
sir.
convince your method to the third party, at that time you need to pass through certain tests and certain kind of procedure. So have you thought about that?
Yes, sir. I have to go with the system camera, sir, which has the higher precision of pixels. So, when you're going with manual lifting, or there are many different procedure to lift the fingerprints, sir, like chemical process, dusting process. Hope you
Uh,
have
uh,
seen. Yes, sir.
my
So,
I think you have not understand my question. My question is,
mm,
suppose you have succeed into this particular research. Now
yes, sir.
that particular research would be implemented by the third party agencies. Okay, so
Yes,
how
sir.
you are going to convince those agencies regarding your research? Is there any particular steps you need to follow? Or once
Uh,
you will have the research over, then you will
mm,
find the certain paths and ways to convince those third party. Is it fine?
yes, sir. Yes, sir.
Okay,
Once it
okay.
has been.
Okay. My second question, or you can say that the suggestion is, you have utilized the weighted hybrid optimization technique, right?
Yes, sir.
Into your research. Any
Yes,
other
sir.
technique have you tried, or this is the technique that is what you have directly utilized?
So before I have worked on computer vision algorithms, sir, that is
Okay.
AKs and SURF method. Comparatively, when to those algorithm, these algorithms are better, sir. Over there, I
Okay,
have
okay.
got 93% correct information, and here I am getting 99% correct information of the accuracy of the fingerprints, sir.
Okay. Fine. All the best for your future. Thank
Thank you,
you.
sir.
Over
Thank
to
you.
you, Karthik.
Thank you, sir. Now, moving towards the next presentation. For the next presentation, I would like to call Kunal for the paper title Enhancing Cassava Disease Detection Integrating Stacked CNNS with ResNet 18 Feature Extraction. I request the presenter to kindly proceed with their presentation. I request the presenter to kindly proceed with their presentation. Moving forward to the next presentation. For the next presentation, I would like to call Dipanvita for the paper title Enhancing Consumer Decision Satisfaction in Agriculture Products Retailing Through IoT. I request the presenter to kindly proceed with their presentation.
Thank you, sir.
Ma'am, you can proceed.
Okay, sir. Is my screen visible?
Yes, ma'am, we can see your screen.
Okay, thank you. Very good morning to all. And today my topic is enhancing consumer decision satisfaction in agricultural product retailing through IoT. I'm Dipanita Chakraborty presenting this paper. Uh, Retail landscape is being redefined by technology. Technology is guiding the retail industry about how the products will be bought and sold. Unlike other sectors, agricultural industry has not embraced a digital solution so easily. Rather, it preferred to continue with the traditional distribution channels. The arrival of Internet of Things or IoT has brought immense opportunity for agricultural product retailing as it gives real-time data, it captures real-time data, it can establish a seamless supply chain involving consumers, farms and stores. This study focuses on how IoT led to innovative agricultural retailing by exploring online and offline distribution channels. This phygital environment takes a pivotal role in shaping consumer decision satisfaction. So, our objective of the study is to determine how IoT can help enhancing consumer decision satisfaction. So, first we will consider some study constructs that we have used in our model. First one is processing fluency. This is actually processing fluency through IoT. This tends to analyze the ease of processing the information content with which the operation will be executed. So we are considering here with the hypothesis that processing fluency through IoT positively affects mental imagery. Now, what is mental imagery? Mental imagery, that is having a mental imagery, is one of the common experiences with consumers. It takes place when people have sensory experiences by producing mental images. Such mental simulation triggers anticipation of emotions like hope, anxiety, trust, etc. among consumers related to their future purchase behavior. So we are considering that mental imagery positively affect anticipated emotions of consumers. Now, considering the anticipated emotions of whatever we have already told, that is mental imagery and perceived ownership we are talking about in the next hypothesis. Now, perceived in ownership, we are considering that this is actually the representation of sensory information about products triggers mental images among consumers that infuse a sense of groundness, which gradually activates in them a feeling of ownership of the products. So we are considering here also the mental imagery positively affects perceived ownership. Anticipatory emotion, which we have considered in the previous one also in our second hypothesis, that a mental imagery positively affects anticipatory emotions. So now I'm talking about anticipatory emotions, what it is. Anticipatory emotions like hope, curiosity, pride, excitement, these things, these often motivate consumers towards positive decision making. So we are considering anticipatory emotions positively affects decision satisfaction, because people have uh, some risks whenever they are taking decisions. They have some perceived risk whether the decision will be correct or wrong. So when consumers find a meaningful association with the purchase through apps, they anticipate happiness before consumption, with strengths that which will strengthen their final outcome of purchasing decision. As consumers develop an intense emotional attachment with the target products through apps, it motivates for ownership, which positively influence their purchase decision. That's why we are considering perceived ownership positively affects decision satisfaction. This is our model, that processing fluency is positively impacting mental imagery, which is again positively impacting anticipatory emotion and perceived ownership. And both anticipatory emotion and perceived ownership are positively impacting on the final output of the model, that is decision satisfaction. So we have, this is a survey based study. We used cross sectional online, we did a cross sectional online survey. We considered the respondents, Indian respondents aged between 18 to 65 years. The survey was done between June 2024 to August 2024, involving 376 Indian respondents. We used a 5-point Likert scale, where 5 and 1 are being considered as strongly agree and strongly disagree. Respondents were chosen through a convenience sampling method, and we used SPSS 28 and DEMOS 28 software. First we ensured that there is a common method bias. The probable impact of common method bias, we ensured that by by assuring the confidentiality of the statement that our respondents are giving. And also we have tested the Harman single factor test, which we found the result is within the threshold limit of 50%. Now, this is the demographic profile of the respondents that we have considered: the ages, qualification, income, and gender. So this is the qualitative analysis that we have considered here. We have used NVivo software for the qualitative analysis. An open-end questionnaire was constructed after validating the questions through extensive literature search, and was asked to pool of respondents, group of size 31. After analyzing and coding the transcripts, some themes of constructs were identified, like processing fluency. These you can see the bigger font size words. These are actually guiding us that which can be our probable constructs, like processing fluency, mental imagery, anticipatory emotion, perceived ownership, and decision satisfactions. Actually, we coded the statements that are being used by the respondents repeatedly. So those
Sorry to
statements,
interrupt,
whenever
ma'am,
repeated.
but you have 1 minute to conclude.
Okay. So this is the measurement model that we can consider here. All CR, AV, MSV, and ASV within the threshold limit, we can see CRs are less than 0.5. CRs is what? This measures the internal consistency. Okay. That is whether the items, whatever we are considering, that is explaining the construct. Okay, and AV, that is average variance extracted, MSV, that is maximum shared variance, and ASV, average shared variances. These are actually considering that the constructs are unique. Okay, there is no overlapping among the constructs. The diagonal values that we have been made in bold, that is the root over of AV, these are showing that these are less than the other values. Like I'm just giving one example. For processing fluency, it is 0.785. We are, this is one with one, that is the impact of processing fluency with processing fluency correlation. But see, for mental imagery and processing fluency, that is with one, is lesser, the value is lesser than the mental imagery with mental imagery, 2 with 2. So this also established that there is no overlapping of the constructs. Now this is a structural model. We are considering the hypothesis, all the hypotheses are being accepted because we are getting a positive beta value, and we can see the highest beta value is with DS and PO, that is a perceived ownership and decision satisfaction. We can see all the fitness values like chi-square by DF, GFI, NFI, CFI, TLI, and RAMSA are within the threshold limit, accepted threshold limit. So here, from here, we can see, I'm just going back to my model, we can see that we have established that processing fluency positively, significantly impacting on mental imagery, which is again significantly impacting both in anticipatory emotion and perceived ownership. And the combination of anticipatory emotion and perceived ownership is assuring the decision satisfaction, that is consumer can minimize the risk in agricultural sector. The theoretical and managerial implications are there, like whenever we are integrating processing fluency, mental imagery, and decision satisfaction, it will actually enhance the existing literature, because there is no existing literature who is focusing on these factors, and not focusing, not guiding that how consumer can have decisions satisfaction in agricultural sector. And highlights of IoT's role, actually it is in enhancing the perceived authenticity and freshness in agricultural product retailing, which is as agriculture, in agricultural sector, retailers are selling perishable products, so this is highly important. And this explores the impact of personalized recommendation, which will actually help out the farm. Okay, real time tracking and optimal storage conditions, it will help out the farm to decide about that how they can plan to reduce waste, how they can plan their product distribution so that they can reduce waste and can earn consumer trust. So as a conclusion, we can say that this study has discussed the potential scope of IoT in agricultural product retailing. It has shown how IoT can create a favorable mental imagery through establishing a seamless processing fluency, which can involve and absorb the consumers to a notable extent so that they can get satisfied with their decision made. The combination of IoT and supply chain can create a personalized shopping experience and can assure the product prices. Thank you.
Sachin, sir, do you have any questions?
Yes, I have one question.
Yes.
Deepanvita,
Yes.
you have presented a very nice work. In this work, you have utilized the IoT algorithm, for the benefit of the consumer as well as the retailer. Okay.
Yes. Yes.
So my question is, at certain level, you need to convince the consumers
Yes.
and as well as the retailers. Okay.
Yes.
And also
Yes.
sometimes you need to, explore your research among the, large community of the farmers and all. So
Yes.
for
Yes.
that also, you need to, adopt certain strategy to
Yes.
express and to, explore your research. Have you
Yes.
thought about that?
So actually, we thought that here we have used a convenience sampling, that is very much a local area based. So whatever we have thought, we
Okay.
can use the method in different geographical locations so that we can be confident about the results that we are getting. And after we get confident, we can convince the retailers to try it out, because we will have some case study base wherever we'll have a detailed data from different geographical location, so that definitely it will create confidence in retailers mind so that they can adopt this method.
Right. I think my gentle advice to you that, as you have rightly said, you need to, divide or scatter the geographical area based
Right.
on your research, and based on that later on you can convince the person or the people or group of people, so that
Right.
your product, or I mean your research could be best suitable for the users. Okay, thank
Okay.
you.
Fine,
Thank you
sir.
for
Thank you
the
so much for your valuable
over
advice.
to you,
Thank
Karthik.
Thank you, sir. Now we are moving towards the next presentation. Just a second. There's some technical glitch. I will be back in 5 minutes. Thank you. Moving on to the next presentation. For the next presentation, I would like to call Kush for the paper title Enhancing Search Efficiency, a personalized profession based approach using AI/ML driven browser extensions. I request the presenter to kindly proceed with their presentation.
Yes. Am I audible?
Yes, sir. You can proceed with your presentation.
Yeah. Is my screen visible?
Yes, sir.
Yeah, okay. So, good morning, esteemed members of the conference. My name is Khush Zamre, and I am honored to present our research on enhancing search efficiency for professionals through personalized, profession-based search using AI/ML-driven browser extensions. Before we dive into the details, allow me to briefly introduce the team behind this project. I am Khush Zamre, the lead author, and I am joined by my co-authors Amol Wagh, Sukhada Mahale, and Dr. Mayank Sohani. We are all affiliated with NMIMS MPSTMI Shirpur, India, where we focus on leveraging technology to solve real-world problems. About the abstract, our research addresses a critical gap in the way professionals interact with search engines. Generic search engines often fail to cater to specialized needs of professionals due to the ambiguity of terms like Amazon or pipeline. For instance, a search for Amazon could refer to the e-commerce giant, the river in South America, or even the tech company's cloud services. Our solution is a browser extension powered by AI/ML that dynamically re-ranks search results based on users' profession and interest, enhancing relevance and saving valuable time. About the problem statement, let's begin by understanding the problem we are addressing. Current search engines prioritize generic search results over niche professional content. This leads to irrelevant and overwhelming search results, forcing professionals to spend significant time filtering through irrelevant information. For example, a healthcare professional searching for COVID-19 treatments might be inundated with news articles and blog posts instead of medical journals and research papers. This not only hinders productivity but also affects the efficiency of their work. Proposed solution. Our proposed solution is an AI/ML-driven browser extension that dynamically re-ranks search results based on users' profession, interest, and behavior. This extension utilizes federated learning to ensure privacy and incorporates a hybrid re-ranking system that leverages both content-based and collaborative filtering techniques. This approach ensures that professionals receive highly relevant and personalized search results tailored to their specific needs and preferences. The core AML models and techniques. To achieve this, we employed several advanced AI and machine learning models. First of all, BERT. It provides a contextual understanding of queries, resolving ambiguity in terms like Jaguar by identifying the user's intended meaning. For example, a search for Jaguar could refer to the car manufacturer, the big cat, or even the operating system. BERT helps disambiguate these terms based on user's profession. TF-IDF. It identifies a keyword relevance in documents, ensuring that the most relevant content is prioritized. This is particularly useful for professionals who need to quickly access the most pertinent information. Word2Vec maps semantic relations between terms, enabling the extension to understand users' search intent more accurately. For instance, a search for machine learning might also return results related to artificial intelligence or data science. Our hybrid system combines these models for improved accuracy and precision in re-ranking search results. About privacy with federated learning. Privacy is a cornerstone of our solution. Traditional search systems collect and analyze user data, centrally posing privacy risk and potential misuse of sensitive information. Our proposed system employs federated learning, training models on device, and eliminating the need to send sensitive data to centralized servers. This ensures that user privacy is protected at all times. For example, a user's search history and preferences are processed locally on their device, ensuring that no personal data is ever transmitted to external servers. As on the right-hand side, you can see the architecture of our project, where we have used cloud backend, ML model REST APIs, cloud storage. And basically, the pop-up HTML will be a front-end interface, and it will send the request into the content script, and it will be injected into the Google search. Then it will forward go into the background script. It will be stored in the local cache storage of the Chrome, and then performing AI/ML on it, we will get our search results. About the hybrid re-ranking system. Our hybrid re-ranking system consists of two key components: content-based filtering, which matches search queries to the user's profession and historical search data, providing tailored results. For instance, a software engineer searching for pipeline would receive results related to CI or CD tools and DevOps practices, while a healthcare professional searching for pipeline might receive results related to clinical trials and drug development. Collaborative filtering leverages search patterns from similar users, offering relevant results based on collective expertise of peers. This ensures that users benefit from the knowledge and experiences of others in their field. Use case scenarios. To illustrate the effectiveness of our solution, let's look at some use cases scenarios. Healthcare. A search for COVID-19 treatments would return medical journals, research papers, and clinical guidelines, providing healthcare professionals with the most up-to-date and relevant information. Software engineering. A search for pipeline would return CI/CD tools like Jenkins and GitLab CI, software development frameworks, and DevOps best practices, helping software engineers find the tools for the techniques they need to streamline their workflows. Finance. A search for portfolio optimization would return academic papers, financial news, and investment tools like Bloomberg Terminal, enabling finance professionals to make informed decisions based on the latest research and market data. Environmental science. A search for Amazon deforestation would return NASA reports, WWF studies, and scientific publications on deforestation, providing environmental scientists with the data they need to understand and address this critical issue. Our system architecture is designed for efficiency and scalability. It consists of three main components: the ML layer, which handles the machine learning models and re-ranking algorithms; the content script layer, which modifies search pages dynamically using JavaScript, integrating the re-ranked results into the user interface. This ensures a seamless and intuitive user experience with personalized results displayed directly on the search page. Deployment. The extension can be deployed as a lightweight solution using TensorFlow.js for on-device processing and as a cloud-based service for using a Flask API. This flexibility allows us to cater to different user needs and preferences, ensuring wide accessibility and usability. Key benefits. So first of all, it is the user satisfaction, which is improvement in result relevance significantly enhancing user satisfaction. Users save time and effort filtering irrelevant results, enabling them to focus on their core task. For example, a healthcare professional might save several hours a week by quickly accessing the most relevant medical journals and research papers. Additionally, our solution avoids manipulative ranking practices, promoting fair and transparent search results. This ensures that the users receive unbiased and reliable information, fostering trust and confidence in search platform. Ethical considerations. Ethics are at the heart of our solution. Our federated learning approach ensures no personal data is leaked or shared, protecting user privacy. Our open, explainable ranking algorithms are designed to prevent bias and discrimination. We believe that transparency is crucial in building trust with our users, and we are committed to maintaining the highest ethical standards. We also conduct regular fairness audits to ensure that our system remains impartial and unbiased, upholding the integrity of our search platforms. The challenges we have faced. While our solution offers significant benefits, it also faces some challenges. Scalability, enabling real-time processing of large datasets to deliver fast, personalized search results. As the number of users grow, we need to ensure that our system can handle the increased load without compromising on performance or user experience. Interdisciplinary fields, balancing multiple contexts such as healthcare and data science to provide comprehensive solutions. Professionals often work in interdisciplinary fields, and our system needs to
Sorry to
able
interrupt,
to
sir,
be
but
able
you
to
have 1 minute
handle
to conclude.
the complexity and diversity of their search queries, ensuring that they receive relevant results across all relevant domains. Future directions. Looking ahead, we plan to extend the search capabilities to handle images, videos, and other multimedia content. This will enable professionals to access a wider range of information. Improve the computational efficiency of AI models to enable faster, more responsive search results. We are exploring new techniques and optimization to reduce latency and improve the speed of our search processing. Expand language and regional support to drive wider global adaptation on the search platform. We aim to make our solution accessible to professionals around the world, supporting multiple languages. Conclusion. In conclusion, our solution transforms search efficiency for professionals by delivering highly personalized and relevant results. The core innovation combines AI/ML federated learning and hybrid filtering to provide ethical, scalable, and deeply personalized search experiences. Our vision is to empower professionals with a search platform that is ethical, scalable, and tailored to their unique needs and preferences. We believe that this solution has the potential to revolutionize the way professionals access and utilize information, enhancing productivity and efficiency across various fields. Here are the references. Thank you for your attention and support. We are excited about the potential of this solution and look forward to further collaboration and feedback from the community.
Thank you, sir. Now I request our respective session chair, sir. Sir, do you have any questions?
My question is to the presenter that your research is basically focused on the efficient searching. Okay. And
Yeah.
in this particular, whatever the model you have represented, it includes the JavaScripting, also the AI tool, also the concept of the machine learning, whichever state it may be, level 1, level 2, level 3. Okay. So
Yes.
basically, it is to reduce the searching time so that the best solution could be reached to the user, those who are seeking the solutions. Okay. And
Yes.
one challenge, that is what you have mentioned in your research, that is the global adaptation. Okay. So
Yes.
my point or my question is related with that futuristic aspect. That is how you are going to convince the people or the agencies or the group of people regarding your research, because there are certain software at this moment of time are available for the specific searching. So how you are going to convince the people for the global adaptation? That is also a big challenge. So have you thought how you should proceed?
Yes, sir. There are some current extensions, browser extensions that do work like this using AML. But what they provide is a summary of the given search results. They don't rank them specifically. And if we consider like, let's say I search about something on ChatGPT or on Gemini for specific anything. Yes, I'll get the exact information, but I won't get the details. Like it will just provide me with a summary. And if I need the details, there's this extension because Obviously, a ChatGPT and Gemini and any other AI model will always give summary, but this AI will help re-rank the search results without omitting any details.
Correct. Correct. So I think your research is having the potential, and you looks very clear regarding what you have done and what should be done in your research. So I think you proceed with this mindset, and my best wishes to you. Thank you. Over to you.
Thank you, sir.
Thank you, sir. Now we are moving towards the next presentation. For the next presentation, I would like to call Hemlata Viveka Gaikwad for the paper title Harnessing AI for Personalized Training Opportunities and Challenges. I request the presenter to kindly proceed with their presentation. I request the presenter to kindly proceed with their presentation. Moving on to the next presentation. For the next presentation, I would like to call Ayush for the paper title Inventory Prediction and Waste Management. I request the presenter to kindly proceed with their presentation. Moving on to the next presentation. For the next presentation, I would like to call Hugh Shakti for the paper title Multi-Class Ship Classification of Commercial and Naval Vessel Using Convolutional Neural Network. I request the presenter to kindly proceed with their presentation.
Hello, yes. Good evening, everyone.
Good evening, sir.
Yes, so I will be presenting the paper on behalf of you, Dr. U Shakti ma'am. My name is Aman Parshar, and I'm with my teammate Akash Varma Datla. Okay, yes. So, yes, let's start. My name is Aman Parshar, and I'm with my teammate Akash. I am from SRM KTR, and today I will be presenting our research on multi-class ship classification of commercial and naval vessels using convolution neural networks. So this study aims to improve maritime surveillance for automated ship classification. So what we are doing in this, we are using deep learning based fine grade classification models to classify ships using the high resolution remote images. Yes, so abstract. So in maritime application, they use like normal manual methods to monitor the ships and classify them, which is very time consuming and error prone as well. So to address this problem, we are using deep learning models to classify ship, and we have used FGSC dataset, which has 23 ship categories. However, for this study, we only used 6 specific categories, which are medical ship, hovercraft, submarine, fishing boat, and passenger ship and liquefied gas ship. So we use 4 CNN-based models to evaluate their performance using accuracy, precision, and AUC score, which stand for area under the curve. And we used VGG16, EfficientNet, ResNet 50, and MobileNet V2. So yes, so we use these to find which model will be performing best on this data set. Then we have methodology. Yes. So in this, I will let you know about the data set. Yes. Okay. So yes, we use the, as I told, FGSC data set, and we selected 6 ship categories. Then we applied some augmented techniques such as rotation, flipping, and contrast adjustment to improve the model generalization. Then we use transfer learning So by fine-tuning the pre-trained CNN architectures, we allow us to leverage previously learned feature from large-scale dataset, which makes our model more efficient for ship classification. Then for the training parameters, we use Adam optimizer and categorical cross entropy as the loss function. So this setup helps in achieving stable convergence during training. The tools we use is Python, TensorFlow, and Keras for deep learning implementation and Matplotlib for performance visualization. Next slide, Akash. Yes. So in the architecture diagram, as we can see, we use this data set. We normalizing it, resizing it, zooming, and shifting the images. So we can like increase the number of images as well and increase the variety of the images. So it can differ as well. Then we use the models, VGG16, EfficientNet, ResNet 50, and ModelNet V2. The matrices we use to compare the performance of all the models is accuracy, precision, and AOC. Okay, yes. Next is the result and performance comparison. So as we can see, in the VGG16 had the lowest accuracy at 43.75%, which is expected because it's an older architecture, plus it's only had 16 convolution layers. So that is also a main reason why it's only showing us 43.75% accuracy. Then we got EfficientNet and MobileNet V2 both perform well with the accuracy of 87.5%. And yes, 87.5%, and both got the same accuracy, showing us. Yes, so when we can see that better than these two, we got ResNet V50 version 2, which had the highest accuracy at 87.98%, and also demonstrated the best precision, making it the most reliable model in our study. Then we can also see that MobileNet V2 had the highest AUC score, which means it is highly capable of distinguish between different ship categories. These results, which shows us that modern deep learning models can significantly improve the classification accuracy, making them suitable for real-time monitoring. Next slide. Yes. So these are the graphs, as you can see, for the area under the curve section and the precision section for each model. So VG16 perform like not well in both of the cases. ResNet shows better precision, but less AOC than the EfficientNet and Mobile VNet too. So yes, what's the conclusion and future scope for our study is we actually successfully applied the deep learning models to classify ships from high resolution remote sensing images, and we found that ResNet V52 emerged as the best model in terms of precision, while MobileNet V2 excelled in AOC. So this research help us to contribute in ship classification for maritime surveillance. The future improvements we can do in this is to include more diverse ship types. For now, we only use 6 because we don't have that high computational power, and we wanted to try like which would be like best model for it at first. So we use only 6 classes. Then we can enhance the model interpretability, and yes, these are the things. Thank you. If you have any question, please let us know.
Thank you, sir. I request session chair, sir, do you have any questions?
Yes, Mr. Aman, you have presented a research where you have categorized, and scattered the certain ship categories. And for that, you have utilized the core deep learning models. Okay. So you have presented a very nice and specific research. Only one thing I could not understand from the presentation, that why it is very essential to distinguish, or to scattered or to divide the ship categories, actually, because do this research conquer the any kind of real-time problem or to give the solution of the real-time problem?
Yes, sir. Okay. So what we can do with this is, we know at the borders we can't like survey all the way to the ocean at India. We can take our Indian border, so we can't just survey
Okay.
all the way by like single-handedly. Like in person, we can't detect everything, right? So we can use satellite
Okay.
images to like detect the ship first. Then we can classify it, which type of ship it is, and is it a submarine if we can detect it, which can help us to identify if there is any intruders or is like what type of ship is there? Is it like have the what can we is like it has the authority like to come inside the Indian borders or not?
Okay.
So it can
So
help in that.
yes, correct. It means you are getting the images from the satellite, and based on that, you are going to, I mean, your research is going to classify the type of ship. Okay. So
Yes, sir.
to get the satellite image, you need to have certain permissions from those agencies. Otherwise, you can't directly get the satellite images regarding whatever required for your research. So have you thought about that?
Yes, sir. That is a major thing. For now, we got the data set as for the aerial images, but further,
Correct.
how we are going to do this, we still are looking into it. We saw
Yes,
some.
because
Yes.
yes, please. Yes, please.
Yes, sir. So we saw some ship like NASA satellite images options. So like there are some free options we can select, which can provide us some satellite images, but not that they don't have much better what we can say image quality. So it's hard to like classify them for now. So we are still looking into it.
Yes, because only my suggestion is, see, your research is absolutely wonderful. That is, there is no question about it. But sometimes you also need to see that should I extend my research to that level, which actually I want to, because in some particular research, if you want to, extend the research, certain permissions are required, certain you need to contact certain agencies for that, and it is always a question that that third party or the agency would give you the permission or something like that. So my intention to tell you is, once you get everything in your mind, and once it is done, then you may proceed with your research. But otherwise, your research is very helpful as far as the security is concerned and as far as the classification is concerned. So work on that, and my best wishes to you and your team. Thank you.
Thank you, sir. Thank you so much.
Thank you, sir. Thank you, sir. Now moving towards the next presentation. For the next presentation, I would like to call Bandar Kulkarni for the paper title Artificial Intelligence in Medical Imaging. I request the presenter to kindly proceed with their presentation.
Yes, sir. Thank you.
Sir, you can proceed with your presentation.
Hello, sir. Is it visible?
Yes, sir, your screen is visible to us.
Okay. Good morning, everyone. My name is Mandar Kulkarni. Today, we are excited to present our research on artificial intelligence in medical imaging. This work was carried out with my teammates Parth Masal and Prem Gaikwad under the guidance of Dr. M.P. Turuk. So let's get started. Artificial intelligence is transforming healthcare with VLMs, that is visual language models, which is emerging as a powerful tool. VLMs integrate computer vision and natural language processing to streamline diagnostic workflows, enhance image interpretation, and improve diagnostic accuracy. Despite their potential, most current VLMs are generalized and not optimized for specialized tasks like medical imaging. Fine-tuning these models with domain-specific dataset is essential to unlock their full utility. In AI, medical imaging supports critical tasks such as segmentation, fault detection, noise reduction, and image enhancement, which improving the analysis of diagnostic visuals like CT scans, X-rays, and MRIs. By applying VLMs, healthcare professional gain deeper insights into medical conditions, which lead to more precise diagnosis and better treatment planning. So, yes, this is the block diagram of our work. So here, first the user will give the medical image, then they go through the image pre-processing, which is before being analyzed by the VLM. The VLM, with the help of vector data, then the VLM process and extract the information from the image. Then with the help of vector database and report templates, sends the data to the LLM, which generates a final medical report. In some cases, the VLM can itself generate a primary report. So in our research, we have found two methods, which is using CNN models. Basically, CNN extracts key feature from the medical images and provides structured data to the LLM, which then generates a properly formatted medical report. Then second method is training a VLM on medical data. This method allows VLM directly to analyze and process medical images, assisting doctors in decision making. So this is the flow diagram of data uploading. So in which first the data transmission, which user data are sent securely. Then the data image is normalized to ensure the consistency. Then the important data is extracted from the image. Then file validation, that is system checks for file corruption and format. Then the blurry images and noise are such as salt paper noise are removed, improving the quality of input data for better AI prediction. So this is the selecting right CNN model. In this step, for example, if you are analyzing the brain MRI scans, it would be useless to use a lung disease prediction model. So to select the basically to select the best CNN model, we use an organ identification model to first detect the organ and then select the most relevant CNN model for analysis. Then these are the performance evaluation meter matrix. Then here first is accuracy, where accuracy assesses the general reliability of the model's predictions in segmentation and classification tasks. Then precision, which precision indicates how many anticipated positive outcomes are truly positive, which helps to mitigate the impact of false positive. Then recall. Recall, also known as the sensitivity, evaluates how many genuine positive instances were accurately detected. Then the F1 score, it is the harmonic mean of precision and recall. Then the intersection over union. Intersection over union is commonly used statistic for image segmentation tasks that measures the overlap between anticipated segmentation mask and the ground truth mask. So this is the 3D data set of brain tumor. And this is basically the masking where the exact location of that tumor is detected. This is the 2D data set. And these are the charts which we have found in our survey. Like, then this is the 2D data set for lung cancer. These are the tissues. And this is the performance graph, like results. So yes, in the integration of AI and VLMs in medical imaging has significantly improved the diagnostic accuracy and efficiency. Deep learning, that is CNN, extract the visual features, while VLMs combine images with the textual data, improving the disease detection and report generation. And these are the references which we have used in our research. Thank you.
Thank you, sir. Now I request session chair, sir. Sir, do you have any questions?
Yes, I have a certain doubt and question. Actually, the research is focusing on the, medical imaging and healthcare solutions with the help of AI and machine learning and VLM. Okay. So sometimes I prefer that, yes, AI, ML, also the deep learning, this kind of concepts and the algorithm based on this, which are extremely helpful to the medical services. But also the procedure is also equally important. How and at what particular situation exactly you are going to apply your research. So are you clear in your mind exactly how we are going to help the medical society and how to convince the medical people to adopt your research?
Yes, sir. Like currently, we are focusing on developing the technology and the research. Then, with the help of our guide, we will be, exactly focusing on where to use this technology and in which step of decision making it will be used.
Okay. So always keep in mind that ultimately your goal is to serve the medical society. Okay. So yes, it is fine. Every research is having certain challenges and certain, issues. But you should have clear thought and path in your mind that how you take your research to the level which you have ever imagined. I mean, you have imagined. Okay. So once you are clear with that, then you can proceed effectively and your research would be reached to that particular user. Thank you very much from my side. All the very best.
Thank you, sir. Thank you.
Thank you, sir. Thank you, sir. Now we are moving towards the next presentation. For the next presentation, I would like to call Hemlata Vivek Gaikwad for the paper title Harnessing AI for Personalized Training Opportunities and Challenges. I request the presenter to kindly proceed with their presentation. Moving on to the next presentation, I would like to call Ayush for paper title Inventory Prediction and Waste Management. I request the presenter to kindly proceed with their presentation. Now we are moving towards the closing remark. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for your support during the ninth version and all the previous eighth version of the conference. All the presenters will be getting their digital certificates through email within 2 working days. Further, all the papers have already forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of SMARTCOM 2025. I also thank our session chair for chairing the session. Sir, this is a token of appreciation and love from GR Foundation and team. I request you to kindly acknowledge our participants.
Thank you very much, Karthik and the team of SmartCom for giving me this extremely important opportunity to serve the conference as a technical session chair. Yes, very nice presentations we experienced today. The presentations focused on the farmers, common people, the fisheries, and also the common consumers. And many of the presentations focuses on the innovative novel ideas which could be futuristic, and they also had a clear mindset how they could extend the research to the end users. So yes, it is always very nice to observe and to supervise certain presentations which would be the future of today's research. And all have put their best effort to make the presentation, to give the presentation. And I think a couple of presenters were not in this particular session due to due to certain unavoidable incidences. But otherwise, it was a very nice session. I also inspired from some of the researchers. It will also give me the certain strength to boost my research as well. So thank you very much. Thank you, Karthik, for nicely coordinating this particular session, and looking the same kind of invitation and cooperation also from the SMARTCOM in future. Thank you very much. Thank you.
Thank you, sir. Thank you for motivating us. Now, I request everyone to turn on their cameras for a quick virtual snapshot. Thank you, everyone. Stay safe, stay connected. We'll be happy to see you in 2026, SmartCom 2026.
Thank you very much.
Thank you,
Thank you.
ma'am.
Thank you, sir.
Thank you, ma'am. Thank you, sir.